You think you know what Antarctica is? Ice, cold, emptiness. The edge of the world where nothing burns and nothing lives. A white desert, frozen solid for millions of years, sealed away from the rest of the planet like a secret no one asked to know. But what if I told you that right now, in the middle of that frozen wasteland, there is a lake of fire? Not metaphorically, not a legend, not some ancient myth scratched into stone by people who never actually saw it. A real, living, churning lake of molten rock sitting open to the sky, glowing red and orange and yellow, hissing and spitting against the polar wind. A place where the temperature at the surface reaches over 1,000 degrees Celsius, while outside it can drop to -40. A place that shouldn't exist. And the strangest part isn't that it exists. The strangest part is what it does. Every 10 minutes, like clockwork, it changes. The gas it breathes out shifts. The chemistry of its breath transforms. Something deep inside the earth sends a signal, and the lake responds. Scientists have been watching it for decades. They still don't fully understand it. Welcome to Mount Erebus. Welcome to the fire at the bottom of the world. Let's start with something that stops most people cold. Antarctica is the most hostile continent on Earth. Average temperatures in winter fall below -60 degrees. Winds hit 200 kilometers per hour. There is almost no liquid water. For most of human history, we didn't even know it existed. The first confirmed sighting came in 1820. That's how remote and unreachable it is. And yet, in 1841, a British naval expedition commanded by Sir James Clark Ross sailed into an unknown sea that now bears his name. His ships pushed through pack ice into open water, and there, on the horizon, he saw something that made no sense at all. A mountain, not remarkable on its own. But this mountain was smoking, actively, violently. A column of vapor and ash rising thousands of meters into the polar sky. Ross named the mountain after his ship, HMS Erebus. In Greek mythology, Erebus was the son of chaos, the god of deep darkness, the void between earth and the underworld. It was a fitting name, though Ross probably didn't know how fitting. Because what his ship's name would mark was a place of genuine, literal fire at the edge of the frozen dark. Mount Erebus rises 3,794 meters above sea level on Ross Island, a landmass that sits close to the Antarctic mainland, usually connected to it by ice sheets. It is the southernmost active volcano on Earth. It has been erupting continuously in one form or another since at least the 1970s, possibly much longer. It is, by almost any measure, one of the strangest geological formations on the planet, and at its summit is the lake. Now, lava lakes are rare. On a planet with thousands of volcanoes, only about 5 have hosted persistently active lava lakes in recent years. To understand why, you need to understand what makes a lava lake possible in the first place. Deep underground, magma, which is what we call molten rock while it's still inside the earth, collects in a chamber. From that chamber, a narrow passage called a conduit rises upward toward the surface. At the top of the conduit, if the geometry is right, magma can pool in a crater and stay liquid long enough to form a persistent lake. Most volcanoes don't have this setup. The conduit is too narrow, or the magma chamber too deep, or the heat disperses too quickly. The conditions need to align almost perfectly. Mount Erebus has those conditions perfectly. The lake itself sits in a smaller inner crater, which sits inside the volcano's main crater. It is roughly 20 meters deep. That might not sound like much until you realize that every cubic meter of that lake is liquid rock at over 1,000 degrees, and the lake is in constant motion. Here's where it gets strange. Even in the savage cold of Antarctica, the surface of the lava lake never freezes. It never hardens into solid rock. It stays liquid, always. The reason is convection. hot magma rises to the top of the lake, spreads outward across the surface, cools slightly as it loses heat to the air, and then, because cooled rock is denser than hot rock, it sinks back down. New hot magma rises to replace it. The cycle runs continuously, around the clock, every day, every year, regardless of what the Antarctic winter is doing outside. The lake breathes. It produces a constant plume of gas that rises from the surface and drifts out across the frozen landscape. Carbon dioxide, carbon monoxide, water vapor, sulfur dioxide. The composition of that gas cloud changes constantly, cycling through a pattern that repeats roughly every 10 minutes. For years, scientists watching the lake from remote sensors could see this cycle clearly in the data. The gas output would rise, then shift in chemical composition, then return to baseline, then rise again, over and over and over, like a pulse, like breathing, like something alive. What was causing it? The first instinct was simple enough. Maybe the lake was just bubbling, like a pot of boiling water. Gas dissolved in the magma finds its way to the surface and escapes. That happens. But the pattern was too regular, too consistent, too rhythmic to be random bubbling. There was structure to it. There was a cycle. The conspiracy-minded didn't waste any time. Online forums lit up with theories. Some claimed the lake was responding to signals from somewhere else, a natural radio transmitter, an ancient geological mechanism built into the planet long ago. Others pointed to the name Erebus, son of chaos, and suggested that the volcano was doing something genuinely supernatural, a vent in the planet's crust that connected to something deeper and stranger than we understood. Some went further. There is a persistent idea in certain corners of the internet that Antarctica is not what we're told it is, that the remoteness and the ice are cover for something, that scientific stations are hiding discoveries too significant to announce. Mount Erebus sits at the heart of several such theories. A gateway, a beacon, a machine. The regular gas cycles, 10 minutes, every 10 minutes, repeating with mechanical precision, were cited as evidence that something down there was not natural. The real explanation, when scientists finally worked it out, was not supernatural. But it was, in its own way, astonishing. Researchers combined data from remote gas sensors with computer modeling of the magma system, and they identified two separate processes that together produce the cycle. The first is constant. Deep in the magma chamber below Mount Erebus, gas-rich magma is always rising up through the conduit. Specifically, this rising magma carries carbon dioxide, and it releases it slowly and continuously as it approaches the surface. This baseline flow is essentially steady, the chemical equivalent of a heartbeat that never changes pace. The second process is what creates the rhythm. Roughly every 10 minutes, the conduit releases something more than just a steady flow. It ejects a large blob of magma, a slug of molten rock that rises up from deeper in the chamber like a bubble in a lava lamp. Except the lava lamp is 900 meters tall and filled with rock that could melt steel in seconds. When this blob nears the surface of the lake, it releases a different set of gases. Not carbon dioxide, but water vapor and sulfur dioxide, the chemical signature of magma that originated deeper in the system. The sensors detect both the increase in total gas volume and the shift in chemical composition. The cycle repeats because the conduit keeps producing these blobs at regular intervals, driven by pressure dynamics deep underground. It is, in essence, the earth burping, on a schedule. But that's not the end of it, because superimposed on this 10-minute cycle is another process entirely, what scientists call explosive degassing. These events are less frequent than the regular blobs, but far more dramatic. When one occurs, the lake doesn't just shift its gas output, it erupts. Small eruptions, nothing like a major volcanic event, but violent enough to hurl chunks of molten rock called lava bombs into the main crater. The technical term, lava bombs, is exactly right. They are bombs, blobs of liquid fire thrown into the air and landing with the force of projectiles. The gas chemistry during these explosive events is different from the gas during the regular 10-minute cycle. It comes from even deeper in the system. It has a different signature, which means these two processes, the rhythmic blobing and the explosive degassing, are not connected to each other. They operate independently, two separate systems running simultaneously inside the same volcano, like two different clocks keeping different times. This raises a question that hasn't been fully answered. What else is happening inside Mount Erebus that we haven't identified yet? Researchers have noticed other gas cycles with different periodicities, cycles that are longer or shorter than 10 minutes, patterns that don't fit neatly into either of the two systems described above. What are they? Where do they come from? Are they connected to the other systems, or are there additional independent processes running simultaneously? The volcano may contain not two clocks, but 3 or 4 or more, all ticking away in their own rhythms inside the mountain. And then there's the magma itself. Most lava lakes in the world are fed by basaltic magma. Basalt is the most common volcanic rock on Earth. It's relatively fluid when molten, which is part of why it can form persistent lakes. But Erebus is different. The magma beneath Erebus is a type called phonolite, a much rarer variety. Phonolite is significantly more viscous than basalt. It is thicker, stickier, more resistant to flow. This changes the physics of everything happening inside the volcano. How gas moves through the magma, how blobs form and rise, how pressure builds and releases, how the conduit behaves. Phonolite is rare enough that there are very few other places on Earth to compare Erebus to, which means the models that scientists build from studying this lake can't simply be transplanted to other lava lakes. Erebus is, in important ways, unique, which makes it both more valuable to study and more difficult to fully understand. For the scientists who actually do this work, unique doesn't mean simple. It means years of data collection in one of the most demanding field environments on Earth. Think about what it actually takes to study this place. Ross Island sits inside the Antarctic Circle. Getting there requires either a long ship voyage through some of the roughest seas on the planet or a flight into McMurdo Station, the largest research base in Antarctica, followed by an overland journey up the volcano. The weather can change in minutes. Temperatures can drop to levels that kill exposed skin in seconds. The slopes of Erebus are covered in ice, loose rock, and, closer to the summit, the product of years of small eruptions. Lava bombs. Chunks of once molten rock of every size, some small as a fist, some large as a refrigerator, scattered across the crater rim and surrounding slopes. And yet researchers have gone, repeatedly, over decades. They've hauled equipment up the mountain, installed sensors in the crater rim, set up remote monitoring stations, collected gas samples while standing in terrain that could shift or erupt at any moment. They've retrieved sensors that the volcano itself had partly buried under new ejecta. They've done this in the dark months of Antarctic winter, when the sun doesn't rise and the cold reaches depths that seem almost theoretical. The data they've accumulated has transformed what we know about lava lakes in general. Because while Erebus is strange and specific, the underlying physics, the way gas moves through magma, the way pressure builds in conduits, the way cycles form and maintain themselves, these things are relevant to every active volcanic system on Earth. Volcanologists around the world working on other lava lakes use the Erebus models as reference points. The 5 persistently active lava lakes on Earth are varied enough that each one offers different insights, but similar enough in structure that what you learn from one sheds light on the others. Erebus, for all its strangeness, all its phonolite, and its remote location, and its 10-minute breathing cycle, is a window into processes that operate everywhere magma meets the surface. Here's the bigger picture. There are 5 confirmed persistently active lava lakes on Earth right now. Erebus in Antarctica, Nyiragongo in the Democratic Republic of Congo, Erta-ele in Ethiopia, Ambrim in Vanuatu, Masaya in Nicaragua. Each one is different. Each one sits above a different type of magma chamber, fed by a different type of magma, producing a different set of conditions at the surface, and each one is, from a geological perspective, a direct window into the interior of the planet. Most of what we know about the Earth's interior comes from indirect evidence. Seismic waves, gravitational measurements, laboratory experiments on rock under extreme pressure, computer models. We cannot drill to the mantle. We cannot visit the magma chamber below a volcano. The heat and pressure would destroy anything we sent there. But a lava lake is as close as we can get to a direct observation of what the inside of the Earth looks like. It's the planet's interior, exposed, visible, measurable. When you look at the lava lake on Erebus, you are looking at material that came from depths of tens or hundreds of kilometers. You are seeing rock that was last at the surface, if it was ever at the surface at all, millions of years ago. The gas it releases was trapped inside that rock since before humans existed, since before mammals existed, since before the dinosaurs. It is breathing out ancient chemistry into the polar air, and the sensors we've installed are reading that chemistry in real time. That 10-minute cycle isn't just a quirk. It's a signal. A message from the deep interior of the planet, transmitted in the language of gas chemistry and pressure pulses, telling us something about the forces that built the ground beneath our feet and continue to reshape it. We are only beginning to learn to read that language, and the location adds another layer of meaning. We tend to think of Antarctica as the end of the world, the place farthest from civilization, the coldest and most hostile and least significant continent. But Earth doesn't care about our geography. The same geological forces that built the Himalayas and opened the Atlantic Ocean and keep Yellowstone in a state of low-grade geological tension are active in Antarctica too. Tectonic plates move beneath the ice. Mantle plumes push heat upward. Volcanoes form and erupt and collapse. Mount Erebus is not an anomaly at the edge of the world. It is the same planet. The same forces, doing what they've always done in a place we couldn't see until recently. There is something philosophically significant about the existence of a lava lake in Antarctica. Fire and ice occupying the same space, not just in the same region, but literally on the same mountain, the molten lake at the summit, and the glaciers that cover the slopes below. The temperature difference between the surface of the lake and the surrounding air can exceed 1,000 degrees Celsius within a few hundred meters. It is one of the most extreme thermal gradients anywhere on Earth's surface. It is also, in a strange way, proof of the planet's indifference to our categories. We label places as frozen or burning, alive or dead, hospitable or hostile. The Earth ignores those labels completely. It simply does what it does, driven by physics and chemistry and the slow grinding of tectonic plates, regardless of whether anything is watching. We are watching. We have been watching, with increasing intensity and sophistication, for decades now. The remote sensors on Erebus transmit data continuously. The gas cycles are recorded in real time. Models are updated as new data comes in. And every few years, a team of researchers makes the journey to the summit and comes back with new observations that reshape what we thought we understood. The 10-minute cycle is real. The explosive degassing is real. The phonolite magma is real. The lava bombs are real. The 1,000-degree lake sitting open to the polar sky is real. And under all of it, deeper than we can drill, deeper than we can measure directly, the process that drives it all continues. Magma rising from the mantle, pressure building and releasing, the planet doing what it has done for 4.5 billion years. The fire at the bottom of the world is not going anywhere. Neither is the mystery. The next time you think you know what a place is, what it contains, what's possible in it, think about Antarctica. Think about the frozen continent where, at this exact moment, a lake of liquid rock is cycling through its 10-minute rhythm, breathing ancient gas into the polar air, throwing lava bombs into a crater, speaking in a language we are still learning to understand. The world is stranger than it looks. almost always. The strangeness is just waiting for someone to look in the right direction. And sometimes the right direction is down. If you've made it to this moment, you're already not the same person you were at the beginning. Because now you know, in the coldest place on Earth, a lake of fire is burning, and it breathes on a schedule. There are more places like this, many more. Subscribe, and every week we'll uncover one of them together.